Mm. Hello, my name is Aitor Castellanos-Neri. I'm in EMAG L33472C, and this is my presentation. I specifically wanted to do field effect transistor. So what is a field effect transistor? An FET, or FET, is a type of transistor that uses an electric field to control the flow of electrical current. There are a few types like MOSFETs and JFETs, but they all share the same idea. Instead of relying on physical contact, they use an electric field to influence the current. This is extremely important for electronics because FETs allow circuits to switch or amplify signals using almost no input power. And here's a little picture of MOSFET specifically. So yeah. So how do they work and the role in electromagnetic fields? So I'm going to specifically be talking about MOSFETs. It's just the one that I'm most familiar with, and it just stood out to me the most. So there's three main parts. We have the source, the drain, and the gate. When you apply voltage to the gate, you create an electrical field over here, and this basically controls the number of charge carriers, electrons, between the source and the drain. And more field means more carriers can flow, and obviously less fields means fewer carriers can flow. But as you can see by the little diagram here, it doesn't actually touch the channel directly, and it's the electric field that does the job of the current flow. So obviously, we've talked about it all semester. This is an example of how electromagnetic fields can control motion without actually physical contact. And in this case, it'd be motion of current. So what are some practical applications of field effect transistors? There's an enormous amount, to be quite frank. They're the foundation of microprocessors, which power computers, phones, and basically all smart technology. Um, like this pretty accurate picture, they're seen everywhere. They're also used in amplifiers, which we see in radio, television, communication, phone. They can also be used to create biosensors to detect things like glucose. As since we're using an electric field, there's no need to have such an invasive process inside the human body, and so we can use a lot of biocompatible materials to pretty much, I guess, simplify things and make things better. It's also used in power electronics. They manage those currents in systems like vehicles and solar panels. And obviously, we're using those electric fields without directly touching anything. And all these applications rely on the same principle, which is they use the E field to control current. So why do they matter in electromagnetics? In this course, we learned that electric fields can influence charges. That's the basis of it, whether it's moving or holding it in place. Field effect transistors are direct practical use of this principle we've learned. Instead of pushing charges with a battery or magnet, they use an electric field to manipulate the current, as you saw in the diagram. And without this course and understanding of electromagnetic fields, we could not design field effect transistors, and without them, I wouldn't be able to make this presentation. So in conclusion, they're essentially an example of how electromagnetic fields can be used in real world technology, and they work by creating an E field that controls current without actually any moving parts. So thanks to them, we have fast, efficient electronic devices that power today's world. And here's a little reference that I threw in at the bottom. Thank you so much.